For 1% of the global population, eating gluten isn't a choice, but a medical necessity. Celiac disease is often described as the immune system turning against itself, but what if that immune response wasn't a mistake, but an evolutionary advantage?
So my research asks, are celiac-associated alleles common in today's modern population because their historical benefits outweighed the autoimmune fitness cost? So why do these celiac genes persist? So celiac disease presents an evolutionary puzzle. Genetic variants that increase autoimmune risk, especially in the immune gene SH2B3, remain common in human populations today. This is surprising because harmful genetic variants are usually reduced by natural selection over time. So could celiac genes possibly offer an evolutionary advantage? So we know that research shows that the same SH2B3 variant linked to celiac disease also strengthens the immune responses specifically to bacterial infection and improving survival in sepsis. In our past ancestral environments, where infection was a leading cause of death, stronger immune systems could mean life-saving possibilities. So this suggests that celiac-associated alleles may have been positively selected for because they improved ancestral survival rates. So because we are testing if celiac disease-associated alleles are prevalent in modern populations because the benefits outweighed the costs, we are going to test three things. First, population genetics, in testing whether celiac risk alleles show neutral selection, meaning they persist in populations because of random genetic drift, or natural selection, meaning they persist because of some benefit. Second, immune biology, investigating if these patterns are consistent with the framework of antagonist pleiotropy, in which alleles are maintained because their fitness benefits outweigh their costs. And third, diet evolution, assessing the evolutionary discordance between ancestral and modern high gluten environments. That research will evaluate if the adoption of agriculture and increased gluten consumption and changes to our gut have an effect on celiac disease allele prevalence. Together, these approaches allow us to determine if the benefits from the celiac disease-associated allele risk variants confer a statistically significant fitness advantage that outweighs the modern fitness detriments of celiac disease.
If my hypothesis is correct, celiac disease is more than an immune system gone wrong, but the modern consequence of immune traits that once protected human survival. Understanding this evolutionary origin could reshape how autoimmune diseases are studied, shifting focus towards why certain immune responses persist rather than only how to suppress them.
Resolving the celiac disease paradox can deepen our understanding of autoimmune diseases, guide future immunology research, and help explain why immune systems that once protected our ancestors can create challenges for patients today. For patients and clinicians alike, this research reframes celiac disease not as the body failing, but as evolution leaving its mark.